Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. Today we are going to talk about how do we use data science in understanding and predicting crime. This is going to be a very exciting research work that I will be sort of sharing with you. I will also try my best to keep the presentation as lively as possible. I request you to stick to me till the end. Now, even before I sort of discuss the nuances of this presentation, I want to take you back to a very interesting incident which happened around 3 years back. Kerala police had organized what is known as a national workshop on knowledge management strategies for the police at the police training college in Thiruvananthapuram, right? This was in June 2018. This particular workshop was organized. I had an opportunity to meet various police officers here. Now, usually when we talk about police officers, we usually think that these are people who wear a khaki and they have got a stick to beat with. That's the first image that comes to our mind. But trust me, I've met some of the most intelligent and some of the shrewd minds in this particular workshop. Particularly noteworthy are two incidents which I'd like to share with you. I had an opportunity to sort of listen to the DSP of Palakkad region, who was explaining as to how he and his team used data science, data analysis to apprehend a murder and assault on a particular woman, right? They had absolutely no clue. They had no evidence of who had committed the murder. So what they did is they went on to pull out the call detail records, CDR, and the tower detail records, and they were able to process what happened. They were able to process the CDR details between the victim and the culprit, and they were able to use analysis to apprehend the murder, right? So it goes to show that analysis is something which is used and can be used even more in the field of law enforcement and policing. The second incident was about DIG administration of Maharashtra Police. Her name is Dr. Pragya Sarware. She was just basically giving a demonstration as to how she has used GIS and Power BI to implement certain control systems, right? Now, sitting in her police office, sitting in her police room, she is able to track down as to how many vehicles have been deployed, how many dogs who are part of, how many dogs that are part of the dog squad have been deployed, how many personals are working in each police station, right? And whether this has any relation to do with reduction in crime and such things, right? So this kind of control system that she has implemented, where she has used a combination of GIS and basic data analysis to apprehend a lot of incidents of crime that go on in Maharashtra. Now, as you know, Maharashtra is a very large state. It is not a very small state. It's almost like half of India. And if for you to travel from one end to the other, it's not an easy task, right? So these are two incidents which sort of motivated me, it sort of inspired me to do data science and data analysis work in the field of policing and in the field of crime in the field of crime as well, right? Normally, you see data science being applied in CRM data, right? Customer relationship management, who is a churner, who is a fraud case, how do you identify potential customers? But this is going to be slightly different from that perspective, because we're going to use data science to identify the behavior of criminals, right? Now, I'm sure that everybody has heard of Kaggle. This particular website has a lot of data, and all the data that is there here is all live data. It's all real-time data. There's nothing cooked up or it's not a figment of somebody's imagination. It's all real data. So the first case study which I'm going to talk about is called as time and location profile. Why is it called as time and location profile? Because I have used the time and location to identify the profile of the criminals. This is what I have done. And this particular data set you can still find in Kaggle, right? Please take this presentation purely for academic reasons, not for any other purpose. I'm just showing this presentation to inspire my audience and motivate my audience to do more analysis and to like and appreciate the science of machine learning, statistics, and such things, right? That is the whole point of this presentation. Please don't take it otherwise. So when you go to Kaggle, there is a particular case study here. It's a project which is called as San Francisco crime classification. It is called as San Francisco crime classification. Now, here we are trying to predict the category of crimes that occurred in the city by the bill. Now, those of you who are part of the earlier generation now would recall that from 1984 to 1963, right, during these 30 years, right, roughly 30 years, San Francisco was notorious for housing some of the world's most hardened criminals, notorious criminals on the inescapable island of Alcatraz, right? It has a history of some of the worst crimes being committed and some of the worst criminals being incarcerated there, right? So this is a brief bit of a background about what we are talking about. Now, I'm just showing you a snapshot of the data set which I obtained in the spreadsheet. As you can see here, please focus on the box that I'm showing in red. You can see certain important columns like the date of crime. When was the crime committed? Right. For example, the first row says 13th May 2015 was the time when the crime was committed. It was committed late in the night around 11:53. What is the category of crime? It says warrants, right? Some description of the crime is given like warrant, arrest, and such things. Which day the crime was committed, right? Mostly you can see the first few observations are all data about data of crime which happened on Wednesday. Police district near which the crime was committed, that is column number E, the police district in which the crime was committed. Next, we have resolution of the crime. So some people were arrested or booked. Others, you see no resolution, right? What is the address of the crime? And some lat-long variables are given, latitude and longitude of the area of crime, right? Now, if you're familiar with GIS and such things, you can put this in a BI map, and you can see on a map those areas which are notorious for high incidents of crime, right? And you can also sort of compare it with other areas wherein the incidents of crime may be at a lower level, right? Now, to further dig into this data, you can see the date variable anyway is given. I had around 13 years of data, right? Almost 13 years of data. Interestingly, notice the date is given, but even the time in which the crime happened, that piece of information is also given, right? Now, when somebody gives a data set, right? When somebody gives a data set, forget the statistics for a moment, right? Forget that we have all these tools, science, and technology to analyze the data. The first thing that you need to ask yourself as a data scientist is, does this data set speak to me? Does this data set tell me a story? This is one of the fundamental things that I learned in my career in the early days when I was a statistician, right? When somebody gives a data set, is this data set telling me a story, right? Data by itself is dead. This data has just some facts and figures. It does not have anything more beyond that, right? But when you start slicing and dicing the data set, data starts talking to you. And our job as data scientists, our goal as machine learning experts is to pull out that story from the data set, right? Once you pull out that story, Just verify for yourself, is there any crucial insight which is not apparent from the data set? It might not be visible to the naked eye, but once you analyze the data set, data starts revealing a lot of interesting details. And we are here to pull out those interesting details, right? Otherwise, this data set does not tell me much. So to analyze this data set, I've not done anything sophisticated. I've not used a machine learning or a statistical tool. I've done some very, very simple basic graphs, but these graphs itself tell a lot of interesting details. Let's just look at this. So this is the first set of graphs that I'm sort of showing you. In the x-axis, I have the time. In a day, there are 24 hours. So I've just taken this as a category. Hour of the day is what I'm taking as the category, and the number of incidents of crime, right? I'm plotting along the y-axis. So this is something which I've done for each and every category of crime. You look at arson-related. Arson is something which you may not see in developing countries, but in the developed countries, this kind of crime is mostly prominent. When we speak about arson, what we are referring to is that there are people who deliberately put their own property on fire. And then they fraudulently sort of ask for money from their insurance company, right? So as you can see, the profile of crime, this is a simple line chart. You can see mostly arson-related crime is happening at night, right? It is starting around 2 o'clock and it goes all the way up to 5 o'clock. And post 5 o'clock, it is silent. Then it again picks up at night. So arson-related crime is happening either at night times, right? At night times, most in the day, as expected, you don't see too much of arson-related crime. It is silent. If you compare this with disorderly conduct, the profile itself is very, very different, because suddenly you can see the graph shoot up in the early hours of the morning, around 5:36. Suddenly you see a spike, right? Indicating that most of the disorderly conduct is happening in the early morning. I don't know, it could be, it's just my guess, don't take my word for it. Mostly it could be that there is a pub or a bar nearby and people are having a nice party the entire night and they're coming out and indulging in this kind of disorderly conduct. You see a lot of these activities because sometimes when there are soccer matches or when there are baseball competitions, a lot of people, a lot of these die-hard fans have a gala time, and then they come out and they indulge in this kind of disorderly conduct. So mostly in the VRs, mostly in the early morning, you see disorderly conduct sort of showing up. Now let me just show you another set of data. This is about extortion. Compare extortion with drugs and narcotic. Mostly extortion-related crime is happening in the afternoon, right? It's happening in the afternoon. If you look at drug and afternoon, it starts in the afternoon but goes all the way till night. Till around 8 o'clock, it sort of keeps on happening, right? Now you may ask, what is the use of this? Now, you and I are not police officers, so this might not be of great use to you and me. But if you give this to a police officer, he knows at what time of the day should he deploy resources, right? Should he have police officers work in the night shift or in the afternoon shift or in the morning shift, right? Because considering the fact that police officers, many of these, a lot of these nations have shortage of resources. They have paucity of resources, they have paucity of manpower, and they don't have too much time. How do you allocate resources? And at what time do you allocate resources? That question is getting answered here, right? So it will be of immense help to the police officers if you can just share these results with them. Let me look at another set of data. Note that robbery is another kind of crime. Mostly in the mornings it is silent, but as we move towards the night, around 8 o'clock onwards, you see there's a continuous increase. In fact, the increase happens post 6 p.m. itself. Robbery and such incidents of crime are, increase quite drastically. Compare this profile with gambling, totally different profile, right? You see mostly gambling related crime at around 12 o'clock. or around 1 p.m. This is a hot time wherein gamblers and such people can be caught, right? Goes to show that the moment you slice and dice the data set talks to you, right? Now, let me just jog your memory. Look at this data set. It did not tell me much. This data set was completely dead. It just is a set of facts and figures. It's just a fact table. But the moment I start plotting graphs, simple graphs, doing simple exploratory data analysis, the data starts communicating, right? Let me just make a move on to another set, which is about suicide. Now, again, mostly the afternoon, you see incidents of suicide. Again, in the evenings around 6:37, you see an increase in the number of incidents of suicide. As I said, this tells the police officers at what time should you deploy resources, right? At what time? So this will be a great helping. This can act as a great helping hand to the police officers, because now they can quickly look at the data and they can back up their claims through data-driven decisions. This is one part of the analysis wherein I'm talking about the time, but this is very, very silent on the location. If the police officers turn around and ask me, the time part is fine, but can you specifically tell me the locations wherein you have these incidents of crime? I have to move on to the next level of analysis, right? So even before I move on to the next level of analysis, you can just see some of these forcible assault-related crimes on women, right? Again, forcible assault and non-forcible assault, the profile itself is different. Non-forcible assault, mostly you see in the afternoons, the non-forcible assaults. And as far as the forcible assault is concerned, it is happening at night, right? Around midnight, that's the time when forcible assault on women sort of increases, right? Now, as I was just saying, this is one set of analysis which tells you about what time of the day the crime happens. Now, as far as location is concerned, let me just go back. You can see here, I have just used the district, the police district. This is each of these districts in the x-axis, and along the y-axis, what I've done is the number of incidents of crime I've been able to plot. Let me just show it to you. Again, you can see arson-related, right? We saw that mostly the arson-related crime happens at night. But if you specifically want to know which are the locations which are prone to these incidents of crime, look at this data. Here I'm taking all the districts like Tenderloin, Taraval. You can have Southern District, Richmond, Park, Northern District, Mission area, Ingleside, Central area, and Bayview, right? And the bars indicate the number of incidents of crime, right? Number of incidents are basically the x-axis. That's what I've taken, right? Now you can easily see the longest bar, it corresponds to Bayview, right? So longer the bar, more the number of incidents of crime, and shorter the bar, fewer the number of incidents of crime. That's a simple way to interpret this particular horizontal bar chart. So it's pretty obvious that Bayview is the one which tops the list as far as arson-related crime is concerned. So if you want to stop arson-related crime, deploy your police officers, the best of the police officers at night, and which is the location you need to target. Bayview is the one location where you need to target the most, right? Compare this with assault. We saw assault on women. Again, I've got the set of districts and I'm plotting the number of incidents. If you look at the two areas which top the list, Tenderloin is one area which tops the list. When it comes to arson-related crime, Tenderloin is quite free from arson-related crime. But suddenly you see when it comes to assault, most of the assault that happens in Tenderloin. And the second area which basically tops the list is the Mission area. These are two areas wherein you can see a lot of assault-related crime. Again, the message is very, very clear cut and simple, that if you want to curb, if you want to reduce assault on women and other forms of assault and such things, you have to deploy your police officers, you have to deploy vehicles, dogs, which which help you in tracking the criminals. You can deploy your resources, manpower in these two areas. Okay, something very simple, right? No analysis, no statistics, no mathematics, no machine learning and such things, but simple analysis itself tells you a lot of interesting details. Now, disorderly conduct, if you remember, if you just quickly look at the time, when we were looking at the disorderly conduct, you can see the disorderly conduct happens somewhere in the early hours, right? 5:36, this is the time when disorderly sort of conduct happens. Now, what about those places where disorderly conduct happens? Again, you see Bayview, the last district, which is Bayview, which comes up, and you are able to evaluate and say Bayview is the place where you see a lot of disorderly conduct, right? So within Bayview, you might want to sort of investigate further and see those areas wherein you have a football stadium or a baseball stadium, right? Because people are having a nice party and they're coming out and they're perhaps indulging in this kind of conduct, right? Don't take my word for it. I'm just guessing here. This could be one of the reasons as to why you see a lot of disorderly conduct. Next, let's move on to drugs. Right, we saw that drugs or narcotics-related crime starts around 1 p.m. and it goes all the way in the evening. Now, two districts which sort of stands out would be one Tenderloin and again Mission area. These are the two areas which stand out. Bayview is relatively, I would say relatively, is relatively free from drugs and narcotics, because you can see around 5,000 cases are happening. Roughly around 4,500, and just for calculation purpose, I'm rounding off to 5,000. If you look at Tenderloin, it's around 15,000, 17,000, right? So 3 times higher number of incidents of drugs and narcotics take place in Tenderloin. That is the inference that you can draw. Next, let's look at the last set of charts. Forgery and counterfeiting, right? You see this consistently happening in almost all the districts, but mostly it happens in the southern part, right? The southern district tops the list wherein forgery, counterfeiting, and such things happen, right? Compare this with vandalism. Now, when you look at vandalism-related crime, mostly, again, here you see Bayview, right? You also see Southern District and to some extent even the Northern District, right? The Northern District, the Mission area, Ingleside, Central District also to some extent. All these areas, you see a lot of vandalism, destruction of public property and such things. So the whole point of showing this analysis was to impress upon my audience as to how simple analysis and such things are used to uncover hidden insights from the data set. I've not done anything sophisticated here. I've not applied a restricted Boltzmann's machine or convolutional neural network. Many times, that might not be even needed. Those fancy algorithms come later. But fundamentally, when somebody gives a data set to you, we should be in a position to at least slice and dice the data set and look at certain charts, do a bit of exploratory data analysis, and see if the data set is telling me any story. So this is just a small effort in that direction to impress upon my audience as to how data science can be used even in the field of law enforcement agencies, and how data science is becoming very, very important in each and every aspect of life. So with this, I come to an end of today's presentation. I thank you very much for watching this presentation. I hope that you have benefited from this presentation. I will see you in my next video. Before closing this, I request you to subscribe to my channel and click on the like button. Thank you very much.